Okay, so today's discussion is going to be on this whole idea of our mole roadmap, but we're going to talk about the section that we have not visited yet, which is this idea of volume fill. So we spent the past few days talking about grams and moles and atoms and molecules and how we can convert between those things. And we have this one missing piece of the puzzle, which is volume fill and how it relates to this roadmap. So before we can get into that, we have one big thing we need to define, and we should all have this piece of paper, mole and volume conversions at STP. And so what we need to talk about is, what is STP? So STP is an acronym, and it stands for Standard Temperature and Pressure. So the S stands for standard, the T for temperature, and the P for pressure. And so if we're talking about pressure, then it makes sense that we're only discussing a particular state of matter, as in solid, liquid, and gas. And the idea of pressure relates solely to gases. So this idea is all about gases. So STP is a particular temperature and a particular pressure that scientists have defined kind of as a, what's the word for it? Like a universal standard, if you will. And so a standard temperature that they picked was 0 degrees Celsius. And the standard pressure that they picked was 1 atmosphere, whose abbreviation is ATM. And that's something we haven't talked about yet, but eventually we will get into. But the atmosphere is a unit for pressure. And 1 atmosphere is actually the pressure at sea level. Just for your information. So STP is an acronym. It stands for Standard Temperature and Pressure, and it's a temperature of 0 and a pressure of 1 atmosphere. Now the question is, how does that apply to us and this idea of converting? It's a very simple idea. And so there's a law that says that at STP, all gases let me change that, sorry. Okay, at STP, 1 mole of a gas, any gas, doesn't matter, any gas, as long as it's at the standard temperature of 0 and the standard pressure of 1 atmosphere, 1 mole of a gas will occupy a volume of 22.4 liters. And so now we have this new conversion factor, which is that 1 mole equals 22.4 liters. As long as it's a gas, and as long as it's at standard temperature and pressure, then this conversion factor holds true. If you've ever noticed, there's a beach ball hanging kind of to the right side of the periodic table in our classroom, and it has this conversion factor on there, that 1 mole is equal to 22.4 liters. So if you look closely at your mole roadmap, I probably can't get this. Oh, maybe. Right here, in your road sign that's connecting moles to volume, it says molar volume 22.4 liters is equivalent to 1 mole. So this is our new conversion factor. So let's use this to solve these 2 example problems. All right, so number 1. It says at STP, how many moles are in 6.8 liters of O2? So 6.8 liters of O2 equals how many moles? So as always, we start with what we were given, the 6.8 liters. Draw our line for our dimensional analysis setup. if you need to and you want to, you can use your roadmap. We're in Volumeville. We're going to Moleville. And so, of course, we use this new conversion factor that we just learned a minute ago. We want liters to cancel. We want our answer to be in moles. And that conversion factor that we just learned was that 1 mole of a gas has a volume of 22.4 liters. I do my division. And to 2 sig figs, my answer comes out to be 0.3. And it's actually going to be 0. If you look at your number, the real number that they gave you was something like this. But to only 2 sig figs, the 3 doesn't round that up. So 0.30 moles of O2 is my answer for that one. So very simple. All right, let's do the second one. Second problem says, at STP, 155 liters of CO2 contains how many moles? So again, 155 liters. Draw my conversion factor. I want liters to cancel. I want moles to be my answer. And again, we mentioned this before in another video, that in these conversion factors, the number with mole is always going to be 1. So if you can remember that, you're kind of set for how you put these numbers in. So 1 mole of CO2, in this case, contains a volume of 22.4 liters. Again, I do my division. And to 3 sig figs, this one comes out to be, let's see, it's something like this. So I want to keep these 3. The 9 will round this up. So 6.92 moles would be my answer to the correct number of sig figs. Okay, so there are a handful of practice problems right here. So if you would go ahead and solve those, and I'll ask that the video be paused so that you have plenty of time to solve those problems, and then I will just go over the answers in this video. But go ahead and pause the video so that the students can have time to solve these, and then I'll come back on in just a minute with the solutions and the answers to these. Okay, so we're going to go over the answers, and I'll show you how to do all these, and we'll be done. So number 1, convert the following to moles. So we want moles in all of these situations. All right, so the first one. So here, I'll just write us a note. Find moles. All right, so in A, they give me 16.5 liters of CO2. So again, it's helpful for you to use the roadmap. You might not need it at this point, but we're in volume, going to moles. We're going to use this molar volume idea. Liters will cancel. Moles on the top. 1 mole, 22.4 liters. Do my division. And to 3 sig figs, 0.737 moles would be my answer. B, a very similar problem, 38.4 liters of helium. We want to find moles. So again, it's the same exact setup. Liters on the bottom, moles on the top. 1 mole, 22.4 liters. My liters are gone, leaving me only moles in my answer. To 3 sig figs, 1.71 moles would be that answer to 3 sig figs. And then letter C, they give 325 grams of Cl2. and they want me to find moles. So this one's slightly different. So if you need your roadmap, we'll use it. Where are we starting? We're starting in Gramville, and we're going to moles. And so notice we're not even on this road to Volumeville. This problem has nothing to do with volume. They give me grams, and they want to calculate moles. And so we're following this road, and our road sign says to use molar mass. So grams on the bottom, moles on the top. 1 mole, again, it's always 1 mole. My grams will cancel, and then I'm looking for the molar mass of this guy, Cl2. Well, that means I have 2 chlorines, and each chlorine's mass from the periodic table is 35. So that means chlorine's molar mass, or Cl2's molar mass, is 70 grams per mole. So this number is a 70. And all I have to do is my division into 3 sig figs, 4.64 moles of Cl2. Notice this problem had nothing to do with volume. They didn't ask me about volume. Even though they said it's at STP, that's fine. That just means its temperature and its pressure are given, and they're 0 Celsius and 1 atm, but has nothing to do with the fact that I'm converting grams into moles in that case. All right, so the second set, they want us to convert all of these to liters at STP. So A, they give me 6.3 moles of SF6. So moles to liters on my map, that's moles to volume, and that's my molar volume that we just learned. Moles on the bottom, liters on the top. 1 mole molar volume says 22.4 liters. In this case, it's multiplication. And this time to 2 sig figs. Because of this, answer comes out something along these lines, but I only want 2 sig figs. So I would have to take that down to 140 liters. Remember that this 0 is insignificant because there's no decimal, so only these 2 are your sig figs. So 140 liters would be the correct answer. B gives us 29.31 moles of O2. So again, very similar question to A. Moles on the bottom, liters on the top. 1 mole is 22.4 liters according to this idea of molar volume. Moles cancel. Multiplication. And this time I'm interested in 4 sig figs. And to 4 sig figs, this would be 656.5 liters. All right, if you look at C and D, they're a little bit different in the fact that they give us grams. So C wants to know how many liters are in 685 grams of F2. So this is where your roadmap might really come into play. They give us grams, and we want to find liters. Now notice there's no road. So I have a middleman, if you will. I have to go from grams to moles, and then from moles to liters. So this is going to be a 2-step. So grams to moles first, using this idea of molar mass. That's what my roadmap says. Use molar mass to take grams into moles. So the molar mass of F2 would be 2 fluorines, so 2 19s, which are 38. And if I calculated this right now, I would be in moles. But the question doesn't want me to find moles, it wants me to find liters. So now I'm here, going to liters. So moles on the bottom, liters on the top. 1 mole. Molar volume says that there are 22.4 liters in a mole. My moles cancel. Notice the only unit that remains here is liters. Do all my math. And to 3 sig figs, my answer comes out to be 404 liters. Part D is a very similar question. 45.5 grams of argon. Notice it's the same as question C in that they give us grams and they want to find liters. So we'll have to first go through moles. So grams to moles. 1 mole. We'll look up argon's molar mass. On the table, it's 40. So if I calculated right now, I'd be in moles. I don't want to stop there. I want to take those moles and change to liters. 1 mole has a molar volume of 22.4. My moles cancel. I'm left only with liters. I do the math. And to 3 sig figs. This comes out to be 25.5 liters. And so there's my answer.